So let's start off with our first analysis. The first business analysis that we are going to do is on the destination, or we can apply the same analysis on the source. As I've discussed before, that for a given source ID, for a given trip ID, right? See, the trip ID is same for all these values. You would see that there is basically a circular relationship between a source and destination. So once an item leaves from a source and reaches a destination, then the same destination becomes the source for the next leg of transportation. So from Gurgaon it reached to Muzaffarpur. Now it became the source. From Muzaffarpur it reached to Purnia. So the crux of the matter is that it will be just a repetition if we also did a source analysis as well as the destination analysis. So uh, we'll just target one, and it will cover or it will give insights for both. Okay. So over here, the base metrics, all these we had, okay, doing the same transformation that we did before, converting into date time, and these factors we are making sure that they are into numeric, right? The matrix that we are going to engineer is the delay time, and logically this should be uh, the actual time and minus the reference time. Reference time over here is the OSRN time. Operating on the same logic is the delay ratio. Actual divided by the reference that we have. Movement ratio is nothing but the inverse of delay ratio. So OSRM divided by actual, and idle ratio should is the taking a difference from one. It will give us the idle ratio. Okay. So for doing the seasonality analysis, uh, we have to group the data on a trip ID level, and we are taking a count. Oh, overall count is giving us the number of hubs or different destination and source centers we have in that trip, and we are taking the average of all the time related, I mean whatever features we engineered over here, we are taking the average of that. P90 percentile is basically to speak it out loud that in that entire trip, uh, there has been the maximum delay which has happened is around this value. And yeah, and the feature that we are going to engineer is the delay amplification. And over here, delay amplification is a little. I know it is little tricky to see it this way, but the conceptually is very simple. Here, this the one which I just highlighted will give us the factor by which for a given trip the distance is more, or either it could be less than the mean of all the trips, right? Meaning to say, if I take the mean of all the trips, right, and whatever value I get it over here, I plug it here. Whereas for a given trip, what is the mean distance? So this is going to give us this information that a given trip has uh, in general like more number of destination centers or less number of destination centers as compared to the mean of the population, and this is the average delay ratio. So in average delay ratio, let's say if there are more number of destination centers, so obviously this factor would be more, and a greater number divided by an even greater factor would result in a small amplification. And uh, that is what that is the behavior we are trying to capture from this factor, that we know that if for a given trip there are more number of destinations, so obviously it is inevitable to have more number of delays. But the pain point or the bottlenecks are those trips where we have less number of uh, destinations or sources. At the same time, we are taking longer time than usual to fulfill the order. So we have the data here, either like looking at the data. Now we can apply dot max or dot min operation, basically do a descriptive statistics to reach to the culprits or the defaulters. But we can also be more elegant and draw charts. And over here, we can see that this destination is having the highest delay amplification factor, right? These are the top 10 destinations where we see the highest delay amplification factor. So this chart alone, a business analyst can give it to to the order fulfillment team, and they can ask them to take any action on these centers. Now, given the delay, uh, let's try to see that if there is any pattern that we observe throughout the day. Meaning, we will select each defaulter, and we will try to break it down from the 0 hour to 24 hour, and we'll try to see at what hour of the day is the delay maximum. If so, the let me just try to show you what I mean. So, for example, taking the case of this, if there is no ratio which is like in the red bucket throughout the day, which means that the delay is uniform, I mean, and it is happening throughout the day. But over here, we see that there is a red bucket in this destination, right? 25 25201, and for this as well, we have a red and orange. So there could be specialized treatment given to these destinations to see that why at this 3 a.m., right, we are experiencing more delay. Is there like the congestion is more? Are there less number of like help that is there to fulfill the order? What could be the reason? So this was about the like the time of the day analysis. If we want to have a like a region based analysis, we can also do the same. This was a more specific analysis, destination based, region based. Also we'll be able to see the idle ratio and average delay ratio and do the same analysis. And before we saw what are the delay uh, amplifiers, which centers is acting as a delay amplifier. But at using the same concept, we can also find which centers are acting as a delay absorbers. And by this time, you would have already guessed it, that this is actually the inverse of delay amplification. And to identify top amplifiers, we just have to set the delay index greater than 0. These are acting as an amplifier. An absorber would have a delay index less than uh, -1. I'm sorry, I think I've said 0 over here. It is 1, and this should be less than -1. Let's see. So all these, so from here we cannot pinpoint that which are the center which are acting as an absorber, but you can see that there are this snapshot should be like a happy signal for your organization that you have more number of centers acting as an absorber as compared to centers acting as a amplifier. That is observation number one. Observation number two, if you're not happy with your process, right, that means these amplifier alone itself has a capacity to undermine all these absorptions. So there could be one or two centers which are experiencing so much of delay that a small saving in the other centers is not sufficient. Okay. So we have come to the end of this analysis of this destination. Next, we will have a look at the business analysis and see what are observations we can draw from there.